International System of Units, SI, International Decimal System of Weights and Measures derived from and extending the metric system of units. Adopted by the 11th General Conference on Weights and Measures, CGPM, in 1960, it is abbreviated SI in all languages. Rapid advances in science and technology in the 19th and 20th centuries fostered the development of several overlapping systems of units of measurements as scientists improvised to meet the practical needs of their disciplines. The early international system devised to rectify the situation was called the meter-kilogram-second, MKS, system. The CGPM added 3 new units, among others, in 1948, a unit of force, the Newton, defined as that force which gives to a mass of 1 kilogram an acceleration of 1 meter per second, a unit of energy, the joule, defined as the work done when the point of application of a Newton is displaced 1 meter in the direction of the force, and a unit of power, the watt, which is the power that in 1 second gives rise to energy of 1 joule. All 3 units are named for eminent scientists. The International System of Units, abbreviated SI units from the French system International d'Unités, is the modern form of the metric system and is generally a system of units of measurement devised around 7 base units and the convenience of the number 10. It is the world's most widely used system of measurement, both in everyday commerce and in science. The system has been nearly globally adopted. 3 countries which have not adapted are Burma, Myanmar, Liberia, and the United States. The International System, or SI system, of units consists of a set of units together with a set of prefixes. The units of SI can be divided into 2 subsets. There are 7 base units, every base unit represents different kinds of physical quantities. From these 7 base units, several other units are derived. In addition to the SI units, there is also a set of non-SI units accepted for use with SI, which includes some commonly used units such as the liter. The International Unit, SI, is a modern form of the metric system and is currently the most commonly used measurement system. This system consists of a coherent measurement system consisting of 7 base units and defines 22 units and many more derivatives. Meanwhile, the SI base unit is the 7 units of measurement defined by the System International d'Unités, as the basic set to derive all other SI units, namely SI derived units. This basic unit is commonly used in various measurements, such as measuring height, weight, time, and many others. Here are 7 basic units for the International System, SI. Long. Dimensions of an object which expresses the distance between ends, with the SI base unit meters, m. Mass. A quantity representing weight, with the SI basis of the kilogram, kg. Time. The entire sequence during which a process, action, or state exists or takes place, has the SI base unit second, s. Temperature. Indicator of the degree of heat of an object, has units of Kelvin, K. Electric current. The amount of electric charge caused by the movement of electrons flowing through a point in an electric circuit over time, in the SI base unit amperes, A. Light intensity. The basic physical quantity in measuring the power emitted by a light source in a certain direction per unit angle, has units of candela, CD. Amount of substance. A physical base unit that measures the number of elementary samples, which can be atoms, electrons, ions, molecules, or certain particles, with the SI base unit mole, mole. Advantages of SI units. Although there are several advantages of SI units, yet the following are important from the subject point of view. SI unit measurement is a coherent system of units, i.e., a system based on a certain set of fundamental units, from which all derived units are obtained by multiplication or division without introducing numerical factors. SI unit measurement is a rational system of units, as it assigns only one unit to a particular quantity. For example, joule is the unit assigned to all types of energies. This is not so in other system of units. For example, in MKS system of units, mechanical energy is in joules, heat energy is in calories, and electrical energy is in kilowatt-hour. SI unit measurement system is an absolute system of units. There are no gravitational systems of units in the system. Thus the use of factor G is eliminated. SI unit measurement system is a metric system, i.e., the multiples and the submultiples of units are expressed as the exponents of 10. In the current electricity, the absolute unit of electrical quantities like ampere, A, for electric current, volt, V, for potential difference, ohm, omega, for resistance, Henry, H, for inductance, farad, F, for capacitance and so on, happens to be the practical units of these quantities. The SI system of units applies to all branches of science, but the MKS system of units is confined to mechanics only. Disadvantages of SI units. Following are some of the disadvantages of S.I units. The non-SI time units minute and hour will still continue to be used until the clocks and watches are all changed to kiloseconds and megasecond etc. The base unit kilogram, kg, includes a prefix, which creates an ambiguity in the use of multipliers with gram. The 5 of the units of the International System of Units are commonly used in chemistry, namely length, mass, temperature, time, and amount of substance. The International System of Units, SI, is a modern form of the metric system and is currently the most commonly used measurement system. In international units there are 7 basic quantities used, namely length, mass, time, temperature, electric current, light intensity, and amount of substance. 5 of the basic SI quantities are commonly used in chemistry. An international committee conference held in 1960 concurred on a set of definitions used to describe the physical quantities. This committee and the founded system are called System International, SI. SI units are the measurement systems used generally to measure the standards. SI units play a vital role in measuring standard quantities in scientific and technological research. SI units are a set of basic 7 base units from which derived units are defined. SI units also play a vital role in modern metrology and now they become a part of the foundation of modern science and technology. SI units can be categorized into 3 types: base units, supplementary units, derived units. SI base units are the basic standard units explained by an international system, SI, of units. SI base units are known as the building block of the international system of units because all other units are derived from these basic standard units. Base units are used to express the base quantities, and the other units are used to express the derived quantities which are derived from base quantities and units. Application and importance. Application and importance of all 7 base units in detail are given below. Meter, the unit of length. Physics and engineering, to measure the accurate length in constructing the building and in designing the machinery. Astronomy, to measure the distance between the objects and the measurement is precise and accurate. Everyday life, in our daily life meter is used to measure the length of an object and also measure the distance or the plot size. Candela, unit of luminous intensity. Lighting industry, to measure the precise and accurate luminous intensity which is important in designing and creating a lighting system. Cinematography and photography, to achieve the effective and desired visual effects accurate measurement of light is essential. Vision science, to understand or design human vision aids measurement of luminous intensity is very essential. Second, the unit of time, synchronization, accurate and precise measurement of time is very important for clocks at the global level and also shows an impact on telecommunication and in many other social systems. Daily life, in daily life time measurement is essential to make a schedule and to do work on their given time. Physics experiment, to measure the velocity, speed, and distance time measurement is essential to do work or experiment on time. Kilogram, the unit of mass. Medical field, to make the dosages and the multivitamins the mass of a substance is essential to measure because if the mass is increased to make a low dose of medicine then it can show very adverse effects. Science and industry, to make the chemicals in industry accurate and precise measurement of a substance is very important. Trade and commerce, For fair trading, the measurement of mass is essential. Mole, the amount of substance. Environmental science. In the environment, the amount of pollutants and harmful gases can be measured through a mole. Chemistry. In the chemical reaction of chemistry, the mole is the essential and fundamental part of a reaction or the chemistry experiment. Pharmacology. In the pharmaceutical industry, the precise and accurate measurement of mole is essential to make chemicals and medicines. Ampere, the unit of electric current. Medical equipment. Many medical machines like X-ray machines, MRIs, and CT scans can measure the precise measurement of electrical current. Electrical engineering. To measure the precise and accurate current in electronic devices. Power system. To distribute the electric current in the electrical system and to operate the power system, the measurement of electric current is essential. Kelvin, the unit of thermodynamic temperature. Industrial process. In industries, to manufacture the material, the accurate and precise measurement of temperature is vital. Climate studies. The global and climate temperature change every time, and to measure the accurate temperature of climate, the temperature can be measured accurately. Scientific research. In physics, chemistry, and many other science subjects in which we can perform experiments, the measurement of temperature is essential to run the process of experiment. Interrelationship and derived units. The foundation of all SI units in the SI system are the 7 base units which are interlinked. To measure the complex and difficult physical quantities, derived units are used, which are a combination of 7 base quantities. Some examples are given below. Watt, W. This is the unit of power and can derive from the base unit, J/S. Newton, and this unit is used for force and derived from the base unit meter, seconds, and kilogram. Joule, J. This unit is used for energy and derived from base units like seconds, kilograms, and meters. These are some examples of derived units that are derived from the combination of different base quantities. The evolution and future of SI units. The SI unit's definition can be changed with time to increase precision and stability. Because these units can be used in modern science and technology and also in meteorology processes. The SI system can do more research to evolve modern technology and discover more precise and effective results of their research to make the bright future of SI units. Potential future changes could involve redefining units based on even more fundamental principles or developing new measurement techniques that further enhance precision and accessibility. The International System of Units, SI, plays a vital role in physics, scientific research, pharmaceutical industries, and our daily lives. The 7 base units are the fundamental and the foundation of the International System of Units. These units help to measure all the quantities in a very effective and the results are precise and accurate. With time, science and technology progress, the SI system also tries to maintain more precise and relevant changes in their research. Thank you for watching this video.